Aiforia is a spin-off company of Catholic University of Piacenza in Italy, and is a small company born in 2009 with the scope of supply services to companies and to promote research in the field of environmental fate of pesticides. During the last year, we joined a consortium for assess a project, a founded project of the Marie Curie Action in the framework program 7. The name of the project is Love to Hate. It is a quite funny name to put in evidence the possible beneficial interaction between chemicals and microorganisms in the soil. Within this project has been involved 5 partners, 2 SME, one is Aiforia from Italy, and another one is Innovio from France, and 3 public research centers, INRA from Dijon, France, University of Patra in Greece, and also in Greece, University of Thessaly. Within this project, we have the possibility to exchange people between academia and companies, thanks to several fellowships. And these guys that are young researchers, expert researchers, participate in the project with a very nice activity of exchange of information between industry and the research centers. In 2013, we started with a lab experiment and with a field experiment in our facilities. And this is the starting point of the research activity of the project.
Hello, I'm Panayotis Karas, and I'm a PhD student in the University of Thessaly. I'm here for Love to Hate project, and I'm a seconded fellowship for as an employee of Aiforia. I'm here from since October of 2013 until at the end of March of 2014. And I'm here to set up the laboratory and the field experiment of Love to Hate project. The aims of the project is to investigate the interaction between pesticides and soil microcosms. And we are setting the laboratory and field experiment to investigate these interactions. Here you can see the Love to Hate website, and the website is lovetohate.bio.uth.gr. In the website you can find all the aims of the project, the partnerships and the partners involved in this Love to Hate project, and some of the results that are already founded. Here we are in the field. As I explained in the laboratory, we started here in this field to set up the plots about the big experiment of the field. We set up 40 plots, and we added 3 doses of pesticides, and we have also some controls to control the degradation of the pesticides. And this big experiment started on October of 2013. And then still continuing, taking samples, and as you will see later. So the big experiment will be explained by Veronica Stott, my colleague.
I'm from Germany and I'm doing my PhD at INRA in Dijon in France, which is a National Institute of Agronomic Research. And I'm here for 6 months at Aiforia. So this field is equipped with a weather station for a better interpretation of our results. We have 40 plots here, and we started to apply 3 different pesticides in October in 2013. And the pesticides that we have applied are isoproturon, tebuconazole and chlorpyrifos, which is one herbicide, one fungicide and one insecticide. And we applied those pesticides in 3 different doses. It's a one-time dose, the allowed agroeconomical dose. And we applied also a 2 times dose and a 5 times dose on this field. Today we have one of the sampling days. Today we have one of the sampling day, and in total we sample up to 125 days after application of the pesticides. Today we are at day 100. We are sampling soil on each plot for then perform analysis in the laboratory. To measure the decreasing concentration of the pesticides and also some metabolites which are increasing in the rate of time due to degradation or dissipation in the soil. So now we are taking our soil samples and we will perform analysis in the laboratory.
After collecting all these samples from the field, we are here in the laboratory doing the extractions of the pesticides from the soil. We set up a multi-residual method that in the same process we can extract all the pesticides with one procedure. The procedure is very simple. We are adding a small amount of soil in a small bottle and we extract it with organic solvents like acetone. We are filtering our samples with Buchners, and after that we are doing a liquid-liquid extraction method, and after that we are putting our samples in the rotary evaporator to evaporate all the solvents and have the pesticides in small amounts. So we can put it in the HPLC analyze machine, so we can identify what kind of pesticides we have and the amount of pesticides are still in the field samples.
So if we take a look at the results, we can see that the concentration of the 3 pesticides applied, isoproturon, chlorpyrifos and tebuconazole, is decreasing in the soil with time, which means 125 days. For isoproturon, the concentration is decreasing completely within those 125 days for all of the 3 applied concentrations. For chlorpyrifos it's the same, just that the dissipation is not complete after 125 days. And for tebuconazole the dissipation is much slower and is also not complete in the end of 125 days. In addition to the 3 pesticides, we also measured the main metabolites of those pesticides, which were MD-IPO and DD-IPO and 4-IA for isoproturon. And we could detect MD-IPO and DD-IPO after some days after application. And the concentrations of the metabolites are first increasing and then decreasing due to further dissipation. For chlorpyrifos, we detected the metabolite TCP, and as well as for the metabolites for isoproturon, the concentration was first increasing and then decreasing due to further dissipation. For tebuconazole, we didn't have standards for measuring with HPLC PDA, so one of the future goals will be to perform time of flight mass spectrometry to find also metabolites of tebuconazole.